All right, 11.5, dividing polynomials. So this is a slightly trickier version of what we were doing yesterday. Our learning goal is I will divide polynomials by monomials, and I will divide polynomials by binomials. So yesterday we were dealing with rational functions. Today we're going to be just looking at polynomials. Remember, a polynomial is something that looks like ax squared plus bx plus c, or there are a few other, we can have to the fourth power, to the sixth power, that sort of thing. Monomial, one term. Binomial has two terms. Polynomial can have any number of terms. So the first thing we're going to be doing is we're going to be taking 4x squared plus 6x minus 8, and we are going to divide that by 2x. So right here we're just dividing by a binomial. By a monomial. There's only one term here. This is the easiest way to do this. What I do is I take 4x squared plus 6x minus 8, and I divide everything by 2x. So when that happens, we get 4x squared over 2x plus 6x over 2x minus 8 over 2x. And we wind up with a bunch of rational expressions all strung together. And I just need to simplify this. 4x squared over 2x, well, those x's divide out. 2 goes into 2 once, 2 goes into 4 twice. So I have a 2x in the numerator and a 1 in the denominator. 6x divided by 2x has has an x in the numerator and denominator that divide out. 6 divided by 2 is 3. And then 8 over 2x will simplify to 4 over x. So this would be my final answer here when I simplify that division problem. So if you're dividing by a monomial, just divide each term by that monomial and simplify. All right, we are going to do a quick long division refresher before we go any further. So 456, let's add a 1, 4,561 divided by 3. Let's make it easy. 3 goes into 4,000 1,000 times. That's really what that 1 up there means, but remember we would just do, 3 goes into 4 once. 3 times 1 is 3. Subtract, I have a 1. 3 doesn't go into 1, so I need to bring down the next place value. 3 goes into 15 5 times. 3 times 15 is 5. I have a 0, but I'm not done yet. Bring down the next one. 3 goes into 6 2 times. 3 times 2 is 6. 0, bring down the 1. Oops, that's a 1, not a 0. And 3 does not go into 1, so I need to make sure I put a 0 in the 1's place. So I have a 1 left over. So way back when you first learned this, you would write remainder 1. And then, you probably don't remember doing this, but we could also write this as, that's an R, that's a 1, 1,520 and 1/3. The remainder is 1 out of 3. So this is just something to keep in mind, that that's always one possibility. So there is your long division refresher with numbers. All right, here we're going to be doing long division, but we're doing it with variables. So for this first one, we're not going to have a remainder, just to get the basic idea. So I'm taking c squared minus 14c plus 49, and I'm dividing it by c minus 7. And the only thing I'm really going to look at here is the leading term. So this is c. And I think, what do I have to multiply c by to get c squared? And that would be c. So c times c is c squared. But then I also need to multiply this subtracting 7 by c as well. So that would be minus 7c. Then when I do my subtraction, c squared minus c squared is 0. 14c minus negative 7 is like 14 plus 7c. So that would be negative 7c plus 49. Then I go back to this leading term. What do I multiply c by? Oops, I wrote that in the wrong spot. That goes over the c, sorry. Same idea, but c gets multiplied by negative 7 to give me this negative 7c. So I'm multiplying by negative 7. C times negative 7 is negative 7c. Negative 7 times negative 7 is a positive 49. Negative 7 minus the negative 7 gives me 0c there. 49 minus 49 is 0. So when I do c squared minus 14c plus 49 divided by c minus 7, I get c minus 7 as my answer. So let's do another example where we don't have a remainder. And hopefully you will start getting the idea of what's going on here. So I'm going to do d squared minus 5d plus 7 divided by d minus 4. So I'm going to set it up the same way. D squared minus 5d plus 7 and divide by d minus 4. D times d gives me d squared. So again, I'm only looking at this leading term. So I have to multiply d by d to get d squared. D times d, d squared, negative 4 times d is minus 4d. Oops, forgot my squared. D squared minus d squared is 0. Negative 5d minus a negative 4 is really negative 5 plus 4, or negative d. And then I'm not subtracting anything here, so I just bring down the 7. D times negative 1 gives me this negative d. So d times negative 1 is negative d. Negative 4 times negative 1 is a positive 4. And remember, we're subtracting. So d minus negative d is 0. 7 minus 4 is 3. I can't multiply d by anything to get 3, so this is my remainder. But instead of writing remainder 3, I'm going to write that d squared minus 5d plus 7 divided by d minus 4 equals d minus 1 plus 3, which is my remainder, over d minus 4. Okay, we're going to do another one. This one really is the same as the other ones. There's just a tiny difference. Notice I have a q squared term and I have a constant term, but I don't have a q term. So I really need to rewrite this with 3q squared plus 0q minus 8 divided by q minus 2. So I need to add in that 0 term, or else I will mess up and I'll get the wrong answer. So I need that placeholder term right there. From here, I'm going to do the exact same steps that I did before. 3q squared plus 0q minus 8. All of that divided by q minus 2. So I look at my leading term, q. I need to multiply it by something to get 3q squared. If I multiply q by 3q, I get 3q squared. And then I need to multiply negative 2 by 3q, which is negative 6q. When I do my subtraction, I get 0. 0 minus a negative 6 is a positive 6q. And I bring down that subtracting 8. Now I look back up here. Q multiplied by 6 will give me 6q. So add a 6. Q times 6 is 6q. Negative 2 times 6 is subtracting 12. 6q minus 6q is 0. Notice every single time I'm getting 0 right here, because the numbers I'm picking up here are exactly what I need to get 0, if that makes sense. So negative 8 minus a negative 12 is going to give me a positive 4. q can't go into 4, so that's going to be the remainder, plus 4 over q minus 2. So my answer for this one is going to be 3q plus 6 plus 4 over q minus 2. So your homework is going to be on page 578. You're going to do numbers 1 through 3, 7 to 21 odd, and 18, 26 through 29, and 30 through 33. I don't know why that didn't just say 26 through 33, but whatever. Oops, goes off the page. So that's what you're going to be doing. If you get it, go ahead and stop now. If you don't get it, watch for another minute and I'll do another one and see if that helps you figure things out. So good luck. All right, so here's another example problem just in case you wanted to see one more. I would look at this, x squared plus 4x minus 5 divided by 2 plus x. This is not written in standard form right here, this binomial. So it really should change to x plus 2. And then I'm going to set up with my division bar, x squared plus 4x minus 5 divided by x plus 2. This is just x squared, so I need to multiply x by x to give me x squared. So x times x is x squared, 2 times x is 2x. Then I subtract, x squared minus x squared is 0, 4x minus 2x is 2x. Bring down the next term. X times 2 will give me 2x, so that's a positive 2. And 2 times 2 is 4. So 2x minus 2x is 0. Negative 5 minus 4 is negative 9. And from there, x obviously can't go into 9. So this is my remainder, or this will be minus 9 over x plus 2. So my answer, or my solution, is x plus 2 minus 9 over x plus 2. Or I could also write it as x plus 2 plus negative 9 over x plus 2. It just depends on what you like. So this just happened to be a coincidence that these are both x plus 2. But there was just one more example of how to use long division.